Again, you are welcome in online classes. In class 12th, yesterday we have studied the limit, the method of limit, and the last method we have studied was rationalization and double rationalization method. Today we will discuss about the method expansion method. What do you know by the word expansion? Expansion means to expand something. This method will work if there is some special functions whose expansion we can make. Then I am making the topic expansion method. Okay, first think about expansion method. When we can use the method, we know the most important or the most used method is substitution method, where we directly substitute the value in the function and we get the value of the limit. But we say if substitution method is not working, it means the substitution method is failed. Then we will use the another method, and there are another methods are factorization method, rationalization or double rationalization method, expansion method, x tends to infinity method, simplification method, and DL hospital rule. Then today we are talking about the method as shown here, expansion method. Okay, first we will know when and how the another method except substitution method will work. By substituting, if we get any indeterminate form, then we will use another method. As same here the method expansion. Okay, here we will expand some particular functions, then we will calculate the limit of a function. Then the most used functions I am writing here, particular functions, which can be expanded. The first function I am talking about is exponential function. Okay, an exponential function we can write as e to power x, and its expansion is given as 1 plus x square upon factorial 2 plus x to power 3 upon factorial 3 plus and so on. Second, if we want to expand the function given as e to power minus x, here you can observe the difference. Here I am taking the power as x and here I am taking the power as minus x. Then the basic difference is here the sign is positive and here the sign in front of x is negative. That's why we will put minus x in the place of x in the expansion of e to power x. Here I am putting the value 1 plus, here the value we will put minus x, then we can write like this. Next term, here minus x to power square upon factorial 2 plus minus x to power 3 upon factorial 3 plus and so on. And we can get from here, if we solve these terms, simplify these terms, then we get 1 plus into minus means minus x. The next term is plus x square upon factorial 2. The next term is minus x to power 3 upon factorial 3 and plus and so on. If you are seeing here, you can see the basic difference. Here the terms coming alternate with the terms are coming with alternate signs. First we are taking plus sign, then minus, then again plus, then again minus and so on. Okay, the next expansion we can write a to power x. First we have to know about what is e and what is a, and what is the difference between a and e. As we know, e is taken as basic exponential functions base, where the value of e is taken as 2.718. Then what we can say about the value of a? It may be take any value, like a is equal to 1, a is equal to 1.2, a is equal to 2, a is equal to 3 and so on. Then a can take any value, but you should remember the value of e will always constant, as given here e is equal to 2.718. Then we will discuss about the expansion of a to power x. As you can see here, the base is e, that's why it is coming 1 plus x square upon factorial 2 plus and so on. Then the expansion of a to power x is given as 1 plus x into log of a, and here the base is taken as e, plus the next term will be x into log of ea square upon factorial 2 plus x into log e of a to power 3 upon factorial 3 plus and so on. You can see the basic difference. Here the difference is seen here like this. Here only x is taken, but here we are multiplying x by log base e of a. Okay, then all the values, all the terms of variable of x are coming in terms of x into log of a. Here also x of log e of a, x into log e of a and so on. Then the next expansion we have to define as a to power minus x. The same, the expansion of this function will be same as this one, but the sign will come as alternate order, as you can see here. That's why the expansion will given as x minus log e of a plus next term plus x into log e of a whole square upon factorial 2 minus x into log e of a to power 3 upon factorial 3 plus and so on. The next expansion, the function taken as log base e of 1 plus x. The expansion of this function is given as x minus x square upon 2 plus x to power 3 upon 3 minus x to power 4 upon 4 and plus and so on. But if I take the function in terms of log e of 1 minus x, then the expansion will be given as minus x square upon 2 minus x to power 3 upon 3 minus x to power 4 upon 4 minus and so on. Then the next function taken as trigonometric functions like sin x. The expansion of sin x is given as x minus x to power 3 upon factorial 3 plus x to power 5 upon factorial 5 minus and so on. Again, the expansion of cos x is given as 1 minus x square upon factorial 2 plus x to power 4 upon factorial 4 minus and so on. Next expansion is given by tan x. The expansion of tan x is given as x plus x to power 3 upon 2x to power 5 upon 15 plus and so on. Okay. Next expansion, 10th 1 plus minus x to power n, which is defined as polynomial expansion. 1 plus minus of nx plus n into n minus 1 upon factorial 2 x square plus minus n into n minus 1 into n minus 2 upon factorial 3 x cube plus and so on. Next, okay, you can note down all the expansions. Then we will discuss about most important part, sin x and cos x. How we can get the expansion of sin x and cos x, and then the expansion of tan x. Okay. First of all, we will discuss about the method how we can expand the trigonometric functions. The expansion of trigonometric functions will be obtained by Taylor and Maclaurin series or expansion. First, we will define the Taylor and Maclaurin theorem. If we are taking a function as fx, then the Taylor or Maclaurin theorem will be expand the function fx as at any value a, then the value will be obtained as fa plus f dash of a into x minus a upon factorial 1 plus f double dash of a into x minus a to square upon factorial 2 plus and so on. This is the theorem of Taylor or Maclaurin theorem. Okay, then first we will define the function, or we will take the value of a as 0. If I am taking the value of a is equal to 0, then the simplified Taylor or Maclaurin theorem will be given as f of x is equal to f of 0 plus f dash of 0 into x upon factorial 1 plus f double dash of 0 into x square upon factorial 2 plus and so on. This equation I am taking equation number 1. Okay. If I am taking fx equal to sin x and a is taken as 0, then I will calculate the value of f0, f dash 0, f double dash 0 and so on. Here, first of all, we have to find the value of f0. Then here, by here I am finding the value f of 0 is equal to sin 0, and we know the value of sin 0 is equal to 0. In the next term we will find the value of f dash 0, And to find the value of f dash 0, first we have to differentiate the function, given function. Then the differentiation of function fx is given by f dash x. We have to study it later, but here the compulsory condition that we have to differentiate the function, that's why I am writing here. The differentiation of sin x, we have to remember the differentiation of sin x is given as cos x. Then from here we will find the value of f dash 0. How? And if I put the value of x is equal to 0, then I will find f dash 0 is equal to cos 0, and the value of cos 0 is equal to 1. Next, again we have to differentiate 2 times, then the differentiation of 2 times we will represent f double dash x. Then again the differentiation of cos x, we have to remember the differentiation of cos x is given as minus sin x. Then from here I will obtain the value of f double dash 0 is given as minus sin 0, and we know the value of sin 0 is equal to 0. That's why the value obtained is 0. And again the next differentiation can be calculated. Again differentiating by this function, we will get f double dash x and so on. Okay. Then first we will put all the values in equation number 1. Then the expansion is given by, first we have to put the value of fx, and fx I am assuming as sin x. Then here sin x is given as, first of all we need the value of f0, and f0 is equal to 0. We need not to write this. Again the value of f dash 0, the value of f dash 0 is given as 1. Then we have to write 1 here. 1 into x, that will become x upon factorial 1. It means this will obtain x. Again we will need the value of f double dash 0, and what is the value of f double dash 0? The value of f double dash 0 is again 0. That's why we need not to write this. Again, one terms we can also calculate the differentiation 3 times. Again, if we are differentiating the function sin x, the minus we have to left minus and differentiate sin x, and the differentiation of sin x is given by cos x. Then we will need to find out the value f triple dash 0. The value is given by minus cos 0, and minus cos 0 it means minus 1. Then we need the value here. Okay. The next term, if we want to get, the next term will be f triple dash 0 x cube. We can write f triple dash 0 x cube upon factorial 3 and plus and so on, this type. Then we have to write the value of f triple dash 0. And what is the value of f triple dash 0? It is minus 1. It means here the sign is taken as minus. I am taking the value of f triple dash 0 as minus 1, then minus 1 is multiplied by x cube. Then we will obtain x cube upon factorial 3. As you can see, by substituting the value of f0, f dash 0, f double dash 0, f triple dash 0 and so on, we can see here that the terms of even power, we can see the value of the terms of even power is cancelled or is missing, and we are getting only odd powers terms. It means x to power 1, then x to power 3, then again, as you can see here, the next term will be x to power 5. Okay. And second thing, we can see the sign is taken in alternate order. Okay. first we are taking plus sign, again we are taking minus sign, again the sign will be plus sign, and it is x to power 5 upon factorial 5 minus and so on. Okay, this is the expansion calculated by Taylor or Maclaurin theorem. You have to note down. Again we will discuss the expansion of cos x. If I am taking second part, if I am taking fx is equal to cos x, then we need again the value of f0. Here the value of f0 is given as f of 0. We can find the value of f0, it is cos 0, and cos 0 we know it is equal to 1. Next we will find f dash 0. To find the value of f dash 0, first we have to differentiate the given function, and if we differentiate the given function, then we will write f dash x, and the differentiation of cos x is given as minus sin x. Okay, then again we will find the value of f dash 0 it is equal to minus sin of 0, and we know the value of sin 0 is equal to 0. In the next condition or in the next term, we will again differentiate the given function at 2 times, then again differentiate the function, it is given as f double dash x, and it will be equal to minus, and the differentiation of sin x is given by cos x, and if we put the value of x as 0, then the f double dash 0 will be given as minus cos 0, and minus cos 0 it means cos 0 we know equal to 1. In the next condition we will obtain, we have to need the value of f triple dash x, it means again differentiate, minus is left, and the differentiation of cos x is given by minus sin x, then minus into minus plus, we can write like this, minus into minus sin x is given as cos x. Then we will find the value of f triple dash 0, it will be given by f triple dash 0, it is equal to sin x, then sin 0, and sin 0 we know equal to 0. Again if we need 4 times of differentiation, then again we will differentiate the function sin x, and we will obtain cos x, then f 4 of 0 is equal to cos 0, it means 1. Okay, then we have to put all the values in this equation number 1, then the function is given as cos x, then we will obtain cos x is equal to, first we need to put the value f0. What is the value of f0? It is equal to 1. Then 1 we have put, again the value of f dash 0, here you can see the value of f dash 0 it is equal to 0, need not to write, and again we need to write the value of f double dash 0. What is the value of f double dash 0? You can see the value of f double dash 0 is, it is equal to minus 1, it means here the sign is taken as minus, and the multiplication will be x square, then x square upon factorial 2. Again you can see, if we put the value of f triple dash 0, it will be 0, that's why this term will become equal to 0, we need not to write this. Again the next term, if you can see here, the next term will be 4 times differentiation of fx and divide by factorial 4 and multiply by x to power 4. What is the value of 4 times differentiation of fx? It is equal to 1. Then again sign is taken as plus, and the variable power x to power 4 upon factorial 4 and minus and so on. You can see from this expansion here only even powers are taken. In another way we can say here odd powers are left. Okay, and also we can observe second thing, that all the terms are coming with alternate signs. First we are taking plus sign, then we are taking minus sign, again we are taking plus sign, and so on. Two type of expansion, sin x, the expansion of sin x and the expansion of cos x, we have obtained by using Taylor or Maclaurin theorem. If we want to obtain the expansion of tan x, then we have to divide. As we know, tan x we can calculate in terms of sin x and cos x, and tan x can be given in terms of sin x sin x and cos x as sin x upon cos x. We can write tan x is equal to sin x upon cos x. By dividing into sin x by cos x, we will obtain the function in terms of x plus x to power 3 upon 3 plus 2x to power 5 upon 15 plus and so on. In these terms you can write. Okay, next expansion we will see here the expansion of inverse trigonometric functions. The inverse trigonometric functions in class 12th there is a separate chapter of inverse trigonometric functions. Here we need not to know about the basic of inverse trigonometric function. We have to directly apply that how we represent the function as inverse function. Okay, here I am taking the inverse of sin x as given as sin inverse x. Here I am writing the power as minus x. You have to know that this is not the power, this is the notation of inverse function sin inverse x. As we can see, this for this function I will explain like sin inverse x, inverse x. Okay, then we have to write down the expansion of sin inverse x. It is given as x plus x to power 3 upon factorial 3 plus 9x to power 5 upon factorial 5 plus and so on. It is given as this type. Again we have to write the expansion of cos inverse x. How we can expand the function cos inverse x? There is a theorem of inverse trigonometric function that if we are taking a trigonometric function, then second function I am taking the what we can say cooperative function of the given function. If I am taking the function as sin inverse x, then the cooperating function of sin inverse x will be cos inverse x. Okay, then we can write sin inverse x. This is the theorem on both the functions sin inverse x plus cos inverse x. It is equal to pi by 2. And from here, if we want to find the value of cos inverse x, then cos inverse x it is equal to pi by 2. Take this term to this side, then the sign will be minus and sin inverse x. Here the expansion of cos inverse x it is obtained as pi by 2 minus the value of sin inverse x, x plus x to power 3 upon factorial 3 plus 9x to power 5 upon factorial 5 plus and so on. This is another expansion. Third, if we want to expand tan inverse x, then the expansion of tan inverse x it is given as in terms of x minus x to power 3 upon 3 plus x to power 5 upon 5 minus and so on. Okay. Again, if we want to expand a particular function given as 1 plus x to power 1 upon x, it is equal to first we will find the expansion of 1 plus 1 upon x to power x. It is given as e into 1 minus x by 2 plus 11 by 24 x square and so on. If we are expanding the function given as 1 plus x to power 1 upon x, the expansion will be e into 1 minus 1 upon 2x plus 11 by 24 x square minus and so on. Okay, these are two special type of functions. You have to note down. Then in the next step we will also note down the expansion of first, we can see first natural numbers based on first natural numbers, first n natural numbers. Okay, if we want to write down 1 plus 2 plus 3 plus 4 plus and so on plus n, we can write it is equal to sigma n, and it will be equal to n into n plus 1 by 2. Again, if we are writing the square, the addition of squares of first n natural numbers, that will be 1 square plus 2 square plus 3 square plus 4 square plus and so on plus n square. Then it will be given as sigma n square. Then the value will be n into n plus 1 into 2n plus 1 by 6. Again, if we want to expand the expansion of cube of first n natural numbers, the addition of first n natural numbers, 1 cube plus 2 cube plus 3 cube plus 4 cube plus and so on plus n cube, then it will be written as sigma n cube. The value will be obtained as n into n plus 1 by 2 ka 2's whole square. Okay, write down. Okay, now we will talk about some standard limits obtained by expansion method. There are some basic standard limits which can be directly used in any given limit. Okay, then here I am writing some standard limits. Standard limits by using expansion method. Okay, one by one we will study about standard limits, how they will be calculated by using expansion method, and what is the value of the standard limits. Okay, first I am taking limit x tends to 0. First I am calculating the limit, or first I am taking x tends to 0's limit. Okay, the function is taken as sin x upon x, and the limit of x tends to 0 sin x upon x will be equal to 1. This is the most important limit used in the chapter of limit.